Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new topic which is in Laplace Transform, a solution of differential equation. Basically, differential equation means what? We are going to differentiate y of t till nth order, as well as we can differentiate x of t till nth order. Now, what is important? Important one is how to find out the result of nth order differentiation. So that problem we can solve by using or by applying a differentiation properties of Laplace transform. So first of all, let's go through the equation first. Now, if we have a nth order differentiation, or you can say if we differentiate y of t till nth order, then what will be the equation? D raised to n upon dt raised to n, the y of t, which means we are going to differentiate y of t till nth. Now plus a1 is the coefficient or a constant which is produced by after differentiating y of t. Now, so what is that? D by raised to n minus 1 and dt raised to n minus 1 of y of t, which means actually we are decreasing the order of differentiation. And what is the last value where the differentiation is now, we have order 1, and or you can say we are going to differentiate y of t only once, where the constant value is now increased up to a raised to n minus 1. So look at here the value of constant a is goes on increasing, where the order of differentiation is goes on decreasing, and the last one is a n, and the differentiation order is removed, so we have only y of t. Now look at here on the right hand side, what we have? b0 d raised to m dt raised to m x of t, where n and m both are the orders of differentiation and both are different, and we are going to differentiate here the x of t. The same thing I have done over here also, because I have told you we are going to differentiate y of t as well as x of t, but till nth order. Now what is the last value of this differentiation? This 0 will increase up to m, as well as this differentiation order will vary from, or we can say decrease from m to 0. So we have only x of t. Now what is the formula, or which formula you will use to solve this solution? Why it is important? First of all, the important because whenever we are facing nth order differentiation formula, which means we have to differentiate that function x of t or y of t till nth times, and to deal with such complicated part, we can use a formula of a Laplace, the time differentiation property. Now in this time differentiation property, if you go through it, then you will get the idea of what is the solution of nth order differentiation equation, or a simply differential equation. I'll show you the actual formula of first order differentiation, second order differentiation and third order differentiation with initial values. I'll show you what is the initial value and what is the meaning of initial value, but later on. But first of all, what is important? That formula which was derived in differential equations or property of differential equation. Now what is the next step? How to deal with this? Just simply apply Laplace transform on all these equations, but what I'm going to do, I'm going to assume all the initial conditions to be 0. I'll repeat, I'm going to apply a Laplace transform on all this setup or all these equations by assuming all the initial conditions are 0. If we remove initial conditions, then I'll tell you the shortcut. If we are differentiating any function till nth order, then simply multiply the Laplace transform of that function by s to the power n. I'll repeat, what you have to do, if we are going to differentiate any function till power n, then what is the Laplace transform of it? Simply just multiply the Laplace transform of y of t, which is y of s, and what you are going to multiply? The s, and the power of s is nothing but the order of differentiation, which means here we have order n, so of course we'll multiply s to the power n with the Laplace transform of y of t, which is y of s. Now look at here we have a first order differentiation, which means we are going to simply multiply s into y of s, which is Laplace transform y of t, and I'm going to do the same thing with this all equation, because I'm assuming initial conditions are 0. Basically, what is initial condition? Initial condition is the term which is produced due to initial output of system or else initial energies of system. We'll discuss it later on. Now we'll move on to Laplace transform first. So I'm going to apply Laplace transform both the sides, but by assuming initial conditions are 0. So what will be the result? As I told you, if you are differentiating any term till nth order, then we have to multiply that function or Laplace transform of that function by s to the power n. So I have applied a Laplace transform on both the sides and I have assumed all the initial conditions are 0. So what is there? Only the s terms and the Laplace transform of that function and the coefficients of that differentiation. Now you can take y of s common from the left hand side as well as you can take x of s common from the right hand side. Basically, why we are doing this? Because I want to find out a transfer function of nth order differential equation. Now, what is the next step? I'm going to arrange all the equations from the lowest order to highest order of s raised to n. Now, just I have rearranged all the terms. Now what I just want to represent this equation in terms of a transfer function. Basically, what is the definition of transfer function? It is nothing but a Laplace transform of output upon Laplace transform of input. The output is equation is represented by y of s, whereas input equation is represented by x of s. So if I take the ratio of y of s by x of s, what you will get? Let's see. So after taking ratio, you will get this type of equation, where in numerator we have all the b terms and denominator we have all the a terms, but much more important one is here the first value is b0 where the order of s is m, and the last value is bm where the order of value is s is 0. Here the a0 was not there because it is constant and we never considered it. So s raised to n is comes first, and then next term is a1 s raised to n minus 1, and the last one is an where s to the power we have a 0. Now this formula is much more important because if we have s square equation, then simply replace all the m by 2. So my equation will be s to the power 2, this will be s to the power 1, and the last one will be s to the power 0, which will give us a b0, b1 and b2. Similarly, if I denominator, if we have n value 3, which means this will be s cube, this will be s square, s to the power 1, and then we'll get s to the power 0, which means we have a1, a2 and a3 value in the denominator. Now basically, why it is necessary to find out a Laplace transform of this equation? Reason is important. As I told you earlier, we have to find out a transfer function, and it is difficult to find out a transfer function when the order of differentiation is n. So the Laplace transform will give us a solution in a simple way by just assuming all the initial conditions are 0. So in this type of questions, what is important? Which term is important, or which type of questions are important? The first question is always they'll give you a differential equation. Now the statement doesn't matter, but the form solution is matter a lot. They'll give you a differential equation and they'll tell you to find out first of all a transform, or you can say h of s. What is h of s? Basically h of s is nothing but a transfer function. So transfer function means what? We have to assume all the initial conditions are 0 and then go for the solution, or you can say then find out the ratio of output by input, or Laplace transform of output by input. Then what is the next? Next one is they may ask you to find out impulse response. Impulse response means what? If the impulse response is asked, then we have to assume input, which is my x of s, is nothing but my del t. or the impulse function. So simply consider this x of s by del t, take the Laplace transform of it and just simply multiply it on the right hand side. Now they may ask you different types of questions after this, like they will ask you to find out a transfer function. Transfer function is nothing but h of s, and how you are going to calculate the transfer function? By just applying Laplace transform by assuming initial conditions are 0. This will be the first case or for the first question. What will be the second question? Impulse response of the system. How to achieve impulse response? To find out impulse response, first of all you should know what is the impulse response, or where you are going to substitute the values of impulse function. Impulse response means what? If you consider my input is impulse, then the whatever output response y of t you are going to calculate or you are going to achieve is nothing but by impulse response of the system. I'll repeat. Impulse response means what? You have to substitute x of t as an impulse function, that is my direct delta function, and find out the Laplace transform of it, because we are going to multiply this x of s on the right hand side, which means the del of t or impulse function will be multiplied with the function or the response or the result, and then go for the inverse Laplace transform of y of s. Then you will get the result in y of t, which is nothing but the impulse response of the system. And now the third question they are going to ask, which is a step response. How to find out step response? Use the same thing. Step means what? You have to use a unit step as a input, which means this x of s is nothing but my Laplace transform of unit step, which is 1 by s, and now multiply this x of s on the right hand side, which means unit step is multiplied with the function, and then after multiplying this unit step with the right hand side, just find out the inverse Laplace transform of y of s, which will gives us the response, which is nothing but the step response of the system. Response of the system means we have to find out the equation of y of t by applying inverse Laplace transform. Now which response they will ask you? The impulse response. So impulse response means what? We have to consider x of s my del of t or the impulse function. If they ask step response, which means we have to consider x of s is nothing but my unit step, and then multiply the x of s value on right hand side and then go for inverse Laplace transform. Then you will get the value of impulse response and the step response. These questions are simple basically. In exam they will ask you the different question, which is nothing but now the fourth part is total response. How to find out total response? Basically the total response asked in two ways. The first one is, in first case they will simply give you the initial condition value. Initial condition values means what? Basically while calculating h of s we have assumed initial conditions are 0. Now just go through the property of unilateral Laplace transform of differential equation, where in that statement what I have written, I have derived one formula, or you can say a property, which is based on a first order. I have differentiated output or a function only once, that is d by dt I have calculated. And what was the result? S into y of s minus y of 0. That last term y of 0 is nothing but my initial condition. Now while calculating h of s we have assumed initial conditions are 0, but while calculating total response they may give you the initial conditions value. And if they give you initial conditions value, then the result of the response will be changed. Now maybe they give you initial conditions value or may not be. If they give you or if they not, then also you have to find out the total response by applying Laplace transform, inverse Laplace transform on both the sides. One more thing they are going to tell you or to find out in total response or instead of total response. What was that? The result is, or the question will be, ZSR and ZIR. What do you mean by ZSR? ZSR and ZIR means zero state response and zero input response. What do you mean by zero state response and zero input response? First of all, I'll tell you the definition, the zero input response. Zero input response means what? We are not going to apply any input signal on function. Then whatever output response will be there, it is just because of, or you can say due to, initial conditions or initial output or initial energy of the system. I'll repeat. What do you mean by ZIR? ZIR stands for zero input response. Zero input response means what? The output is produced, but it is not because of input signal. It is just because of initial conditions or initial outputs or initial energy of the system. So what we can define this ZIR by? ZIR is the response of the system. It is because of or it is due to the initial conditions, initial value or initial output of the system. Now, what do you mean by ZSR? ZSR means what? It is the output of system which is achieved by applying input signal. But in that we are going to assume all the initial conditions are zero. So ZSR means what? We are going to apply input signal, but we are going to assume all the initial conditions are zero. Then whatever output you will get, and that output is nothing but zero state response. Or you can say zero state response is nothing but the output due to input signal when the input initial conditions are zero. So both the conditions are opposite to each other. Here we have to apply input signal, but initial conditions we are going to assume zero. Here we are going to apply initial conditions, but we are going to assume initial input signal is zero. So basically total response is nothing but the addition of ZSR and ZIR, which means, as I told you, in ZSR they may give you initial conditions or they may not. If they give you the initial condition, then you have to find out ZIR, ZSR, or automatically you can say that in the result you have a ZIR and ZSR values. But if initial conditions are not given, then of course you will get only a ZSR value. So important one is initial conditions, and much more important condition is the formula. I'll show you the formula first. Now, as I told you, the important one is what is asked in question, and second one is formulas. Suppose in your exam, if they give you first order differential equation, first order means what? You can write d by dt of y of t where the order of differentiation is 1, or else this d by dt can be represented by y dash of t. If we have a first order differentiation, then we will use only 1 dash. If we have double order differentiation, then we will use a y double dash. If we have a third order differentiation, then of course we will use y triple dash. Now, what is the formula? This formula we have derived in time shifting property, but in unilateral transform. And the formula is, if we have a single order differentiation, then of course we'll multiply it by s y of s, and the initial condition is y of 0. While calculating, just few minutes before, we have calculated a transfer function. In that, initial conditions which is assumed as to be 0. Only we use this formula. But if we are not assuming initial conditions, then you will get this formula. But if we are assuming initial conditions, then we have to use this formula. Similarly, just go through these two formulas. If we have a second order differentiation, then of course we have to differentiate this function 2 times. You can say that we can represent this equation by like y double dash of t, and the Laplace transform of this is nothing but s square y of s. The shortcut one, as I told you, if we are differentiating 2 times, then of course we have to multiply the Laplace transform of that function and multiply it with the s square. If we are differentiating 3 times, then of course we are going to multiply y of s by s cube. And the next part is we are going to reduce the order of s, that is, in first of all we have s square and then s, and then last one is s to the power 0. But till that we have to differentiate this function. So that's why at the end we have got y dash. So in this last term, what we have, the order of s is going to reduce till s to the power 0. But first of all we have y of s, then next condition is y of 0, and then if we differentiate more, then we'll get y dash of 0, and if differentiate further, then we'll get y double dash of 0. And we have to differentiate this function till we'll get s to the power 0 in the multiplication with the y of s. Now, these formulas are important while solving a numericals related to differential equation of Laplace transform. And the next one is the first important case, how to find out transfer function. You have to find out transfer function by assuming all initial conditions are 0. Initial condition means all these terms we have to assume to be 0. Now second one, on the transfer function or next to the transfer function, they may ask you impulse response and the step response, where we have already ignored the initial conditions. The rest of the part you can do as I told you in previous part. Now, and the last one is a total response. There is a separate question. Basically the first three questions asked separately and the fourth question asked separately. There are two different questions. In first question they may ask you transfer function, impulse response, and the last one is step response, and the another function will be they may tell you to find out only total response or else ZSIR, ZIR and the total response. ZSIR means what? Zero state response. ZIR means zero input response, and the addition of two will be a total response. Now, I'll repeat. What is the formula of ZSR? What is the definition of ZSR? ZSR is nothing but the output of system when the input signal is calculated or input signal is applied, but in that initial conditions we are going to assume it is zero. What do you mean by ZIR? ZIR means what? Zero input response, where the input signal is assumed as a zero, or you can say the output is produced where input signal is not there. So output is produced not because of input, it is just because of initial conditions of system or initial values of system. So right now we'll stop. All this stuff I have explained is important from numericals point of view. So thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda to see next numericals based videos. Thank you so much.